conspiracy theory, and the paranormal meet. And now, we join the show already in progress with your hosts, Adam, Seraphiel, and Rob.
So, contact at the cabin, and we have started, Randall. We're more organic these days than we used to be instead of formal. But contact at the cabin. You just got back. You were there with the Grimerica guys, and I just want to know how it went. Where you guys ended up, what you did. Did you find out anything that was interesting?
Well, yeah, the way it was set up, there was 3 groups that came in over the 10 days. And so I basically took each of the groups to Chimney Rock and to Mesa Verde. And then the third group, we had an extra day. So I took them up to, it's called Treasure Falls. It's on Wolf Creek Pass, which is pretty much right on the Continental Divide, northeast of Pagosa Springs. And that was a great hike up to see this waterfall called Treasure Falls, which comes off of a basalt upland there. And yeah, so it was primarily Mesa Verde, the Green Table, looking at the cliff dwellings and these other Chacoan cultures. This was one of the Chacoan outliers. And then Chimney Rock, which is 2 pinnacle rocks that are just southwest of Pagosa Springs that can be seen from 90 miles away out in the south from another mesa top, and apparently was being used as a signal tower and an astronomical observatory. So as part of this whole Chacoan complex that covers the San Juan Basin and contiguous areas of Four Corners and southern San Juan Mountains in that area, spills over into Arizona. For example, Canyon de Chelly is probably an affiliate group there with the Chacoans. So it was quite an elaborate system, community, culture that they had set up, 1,000 years ago in the deserts, which weren't apparently so desert-like then, and they mysteriously disappeared around the mid-1200s and left this amazing architecture that we now look at and wonder about. And like so many other ancient cultures, they were obsessive sky watchers. And so their whole complex, covering over 10,000 square miles, was all laid out according to the patterns of the sky and tracking mostly lunar and solar motion. So that's what I chose this place because I wanted to learn more about the area. I'd never been to Mesa Verde. I'd been to Chimney Rock twice, but only climbed it once because the second time I went in there, it was nasty weather and they weren't letting anybody in.
Yeah.
So I took 3 groups back. So now I've climbed Chimney Rock a total of 4 times and took 3 different groups to Mesa Verde, and we explored around. There was a lot of overlap and similarity, but each group we did a little bit different one. So I have a pretty good picture in my head now of the whole Mesa Verde. And that was one of the things that was really interesting to me was that I wanted to explore was the geomorphology of the plateau there because of the mesa, because it's deeply dissected with these enormous canyons. This is the Chacoan people utilize these overhanging roofs of these canyons to build their villages. You've probably seen pictures of them. But I was really interested not only in the cultural aspects of who these people were and what they were up to and where they came from and where they disappeared to, but also the geology of the area, and particularly Mesa Verde, and wanted to get a better understanding and get a big picture of how the existing landscape came to be, because it's rather bizarre. And probably need to show you photographs of it, or use Google Earth or something so you can see what I'm talking about. But like I said, it's deeply dissected by this labyrinth of canyons, and the canyons are up on top of the mesa, which is odd because the canyon shouldn't be on top of 1,000-foot high mesa, right? Because you've got deep valleys surrounding the mesa. So then the question becomes, why any major erosional, effects of flowing water would have just surrounded and gone around the mesa? But how do you get that much water up on the mesa itself that it can cut a canyon, 600, 700, 800 feet deep? And I still haven't figured it out yet. So
do you think that figures into the kind of like your whole thing, the comet impact, the cataclysmic theory, the onrush of water? Do you think that may figure into it somewhat?
Yes, and I wouldn't stick my neck out at this point and say that all those canyons were created, like at the end of the last ice age.
Yeah.
But you've got this isolated mesa surrounded by deep valleys, and then on top of it, it's dissected, with these deep canyons. Now, the canyon floors are above the floor of the surrounding valleys, but from the surface, the mesa itself is almost level, but it tilts to the south. And the runoff that cut down these canyons was towards the south. So it would just generally, when you have a major water flow, like if you think of any river, it's collecting streams, right? It's got these tributary streams that flow into it, and then that river may be tributary to a greater river, right? And in a lot of places where you might have a canyon eroded, you've got a huge catchment basin feeding water into that canyon. You may have 100, 200, 1,000 square miles of catchment basin gathering the waters that are then funneled into this one particular river valley that will then carve a canyon. But you don't have that on Mesa Verde. That's the thing I'm getting at. It's like, where's the catchment basin? The whole surface of the plateau is dissected with these deep canyons. So were the canyons cut at some point before the mesa was uplifted? Were they cut after the mesa was uplifted? But in order to do that, it means that these tremendous, deep, huge valleys that surround the mesa had to have been filled with material that's now removed. So it's part of this whole mystery of the extreme erosion that has occurred on the Colorado Plateau that I'm trying to figure out. It was the thing that the early geologists, late 18, early 1900s, as they were traveling over the Colorado Plateau, looking at the extreme erosion, they came up with a term, and they call it the Great Denudation. The Great Denudation. And was it a single event? Was it multiple events? I don't know. But if you spend any time traveling over the Colorado Plateau, which would be, Monument Valley, it would be the San Juan Basin, it would be Canyonlands, it would be Arches, it would be Shiprock, New Mexico. You have evidence of just extreme amount of material that has been stripped off the plateau. And, you've got a lot of limestones in the upper layers exposed, like at Grand Canyon. Grand Canyon is the outlet for the entire Colorado Plateau. So any waters, any rainfall falling over the Colorado Plateau ultimately like the Green River comes from the north, you've got the San Juan River coming out of the San Juan Mountains, you've got the Animas River. All of these rivers are feeding into the Colorado, and then, of course, it's the Colorado that runs through Grand Canyon. So Grand Canyon is like the drainage outlet off of the Colorado Plateau. And when you travel over it, you see that there's just this extreme amount of erosion. I don't know, have either one of you guys been to Grand Canyon?
Yeah, we both have, I think, yeah.
Yeah,
Okay,
absolutely.
so both have. Okay,
Same
you
trip
remember
I
we
went to
on the
Grand
south?
Canyon. I went to Mesa Verde as well. Yeah, last year.
Yeah. Okay. Okay. Well, then you might know what I'm talking about. That you've seen the canyons there. Now, if you're standing on the south rim of Grand Canyon, once upon a time there was another mile of sedimentary rock over your head, and that whole mile of rock had to be stripped away before you could even begin carving Grand Canyon. You see, so it's just kind of an indication of how much erosion has taken place. Now, the question is, over what time span was this erosion? And was it uniform? Was it a consistent process, or was it in episodes? Were there episodes of erosion? And I think clearly the evidence suggests there were episodes of erosion where the rate of erosion compared to what we see now is accelerated by orders of magnitude. And this process, if I had to conjecture, I would guess that this process has been going on for 2.6 million years, which takes us back to a geological boundary called the Pliocene-Pleistocene transition.
Yeah.
And what differentiated between the Pleistocene, which followed the Pliocene, was that during the Pliocene you had this long interval of relatively stable warm climate, and somewhere between 2.5, 2.6 million years ago there was a major shift, and the planet lurched into this oscillating sequence of glacial, interglacial ages, which we're probably still in. The last episode that played out would have been the end of the last ice age at 12 or 13,000 years ago.
Right,
So,
because those interglacial periods lasted. I mean, we're talking about tens of thousands of years.
for the interglacial or the glacial?
Well, the interglacial.
No,
so technically, we could still be in an interglacial, right?
Well, no, I think it's more the question that are we still in a glacial? Because
Okay, I understand.
what is now apparent from the quote-unquote chronostratigraphy is that periods of interglacial warmth, such as we're in now, which is very distinct from the full glacial cold of the late Pleistocene, so distinct that we're now in a different geological epoch.
Yes.
So the Pleistocene gave way to the Holocene, right? Well, if you can go back using ice core data and oxygen 18 isotopes to determine, which is a proxy for temperature changes, what it would suggest is that the longest interglacial period in the last, say, minimum 250, maybe 400,000 years, the longest period of interglacial warmth is the Holocene, our present one. And as more data comes in...
which is about, what, 10,000 years, 12,000 years?
The date now for the Holocene is usually marked at 11,600 years ago. But
the end of the Younger Dryas, right?
The end of the Younger Dryas, right.
Yes.
But even though the end of the Younger Dryas, it was still a very different world because sea level continued to rise post-Younger Dryas up until between 8,000 or 9,000 years ago. Roughly 9,000 years ago, sea level stabilized at the present level, maybe 5 or 6 feet lower. But it was at that point that you could start now evolving coastal communities, because obviously you couldn't establish a coastal community when sea level is still rising, a couple of feet every century or more. So what you see is that around 9,000 years ago, once sea level stabilized, and then with the stabilization of sea level, you had sort of also a stabilization of the global climate. By this time, the post-ice age vegetation regime had been well established. And so really the modern environment, climatological environment, really began, say, around 9,000, 10,000 years at the earliest, but I would put it more between 8,000 and 9,000 years. So even though you say that the Holocene started 11,600, the world was still quite a bit different. Because, again, sea levels were probably 100 to 150 feet lower around that time.
And the climate starts to kind of smooth itself out a little bit. Right.
Exactly.
Over
Yeah,
2,000
that's
years,
exactly right.
3,000 years, yeah.
Mhm.
Yeah.
Yeah. So, and I think, just like, when you have a big earthquake, oftentimes you'll have aftershocks. I suspect we're still seeing declining aftershocks from the Younger Dryas still to this day. I think a lot of the instabilities, seismic instabilities and volcanic instabilities that the planet has experienced in the last few millennium may literally be a legacy of the extraordinary global changes that occurred during the Younger Dryas.
Well, first of all, let me say, Mesa Verde, awesome place. I went there last year. I drove up from the Grand Canyon through the Navajo country. Incredibly pretty drive. Went to Mesa Verde. It was a goal of mine to see that place. And one of the interesting things that I found out that I learned there was that the cliffside dwellings that we see as this kind of great achievement of civilization almost, and it was an achievement, but that was their kind of almost last ditch effort, that some kind of climate change or some kind of warfare took place where they had to hide in the cliffs, and so that actually when they lived on top of the mesa, they were a little better off, and then when they were living like on the side of the mesa and the cliffs, they were a little worse off. So I found that interesting as well.
Yeah, and I don't know what happened. I mean, I heard a number of different conflicting stories. When we went up to Mesa Verde, we went on several guided field trips. And the stories varied depending on your guide.
It's an amazing place.
Well,
though.
I can add a little anecdote. I'm from Arizona. Have family that was involved in the conquest of New Mexico and southern Colorado, and Native Americans as well. But in Arizona, I grew up with a lot of Hopis, and as far as genealogy and I guess the archaeological community is concerned now, they've finally come around to what the Hopis were trying to tell them for a long time, which was that they were the descendants of these of a lot of these groups that of the cliff dwelling people. And now the Hopis in Arizona, where they live on top of the mesa. And so that, like what you said, Adam, as far as the living within the cliffs being some kind of having to fortify or having to avoid some kind of climate thing, because naturally now their descendants live on top of the mesas.
Right, and the word Anasazi, which is now kind of looked at as a derogatory term.
Yeah, it was an old Navajo word.
The Navajo word for ancient enemy.
Yeah.
So there's this thought that it was the Navajo or a precursor to the Navajo that actually fought these people.
Right, but this is all, long spans of time that formal archaeology is just now really trying to get a hold on. I mean, this is only, formal archaeology hasn't even existed for that long of a time, and we're talking about thousands and thousands of years. We really don't have a real grasp of it yet.
But it's very interesting stuff, and one of the things I learned that I knew also though, but was really reinforced in the scale of the cultural interaction and exchange between the Chacoan people and other groups such as Mesoamericans, the Hopewellian groups in the eastern woodlands appears to have been pretty extensive. With extensive trade networks in place. So that was one of the things that it really helped to cement in my mind was you're thinking 10,000 square miles of the San Juan Basin, but then you realize that they are in contact with groups that are in the eastern woodlands of the east of the Mississippi, and in contact with presumably the Mayans. The Mayans were doing a lot of their building. Most of the Chacoan structures were being built between about 950 and 1250 AD. So there was a lot of overlap there with the mound building culture of the Mississippi Valley and the eastern woodlands and the classical Mayan that were building a lot of the the ceremonial complexes and so forth in the Yucatan.
Yeah, why wouldn't there be?
It seems like, yeah, exactly. Why wouldn't there be unless one was making the assumption that these groups were, so primitive that they lived in complete isolation from one another. But obviously they weren't, because they were trading with each other, you know. So, yeah, it's an interesting, and that's what Graham Hancock's book is addressing. I haven't quite finished it yet. I was almost done. I think I had 3 chapters left when this Colorado thing came up. So I now have the updated version. I had the pre-publication version that I was reading that still included typos and things like that. So I'm going to finish the book and see where he's going with it. But basically that's what he's addressing, is this idea that, there was a lot more going on prehistorically in North America than has been previously recognized.
Well, and I guess it's what you could consider a continental civilization, whereas, the same with ancient European history, you have different groups of people, but when they're all interacting and trading, it kind of forms a single civilization.
Yeah, exactly. That's exactly it.
Yeah. So Graham Hancock's book, The America Before, I'm going through it as well, and this whole idea that you have the it's a challenge, one of the many challenges to the Clovis first hypothesis, which I guess is what it is, like 11,000 or 12,000 years ago, and they say that
I
was
think
the first
early Clovis appearance is about 13.4.
Okay.
And then they're gone at 12.9. Basically, they've disappeared at the onset of the Younger Dryas.
Okay. So that's generally the archaeological community has accepted that Clovis first, that's it. Those were the first people that were here. But there's a ton of challenges, and one of the ones that strikes me that's fairly obvious is the one in Chile, which is called Monte Verde, which when you and Graham were in that interview on Joe Rogan's show about with what's the skeptic guy that
Michael Shermer.
Michael Shermer, yeah. When you guys were on that show, he kept saying Mesa Verde, which confused matters, which was interesting. But we're talking about something that's like, I believe, 24,000 years ago or 28,000 years ago, about twice the number of time that between us and the Clovis first. And this is in Chile. This is the tip of South America. Yep. So we have all these, and this is not the only challenge that Graham Hancock points out. He points out the Topper site, which I believe is in South Carolina, Albert Goodyear.
Yeah, we visited that site with Al Goodyear when Graham was researching the book. So I had the privilege and opportunity of getting in. It's a closed site, and it's on private property, but Goodyear arranged for us to get in, so I was able to see for myself the Clovis layer and the pre-Clovis layer that has dated to 50,000 years old.
Yeah.
So, pretty interesting stuff. Yeah, and Graham does talk about a lot of this in his book, the accumulating number of earlier dates that is pretty much blowing the Clovis first theory right out of the water. Now, the Clovis is still an interesting question in itself, like where did they come from? Because they show up very suddenly, and then they disappear very suddenly. Now we can locate in time their disappearance with the onset of the Younger Dryas, but at between 13.3, 13.4, when they first show up, I mean, where did they come from? I don't know. That's an interesting question in itself.
Yeah, I mean, I think it almost seems to me that there is this now this view that is now coming into vogue, where they're looking at that there could have been many different kind of peopling of the Americas. You could have had the Beringian Strait. He talks about in the book about the Melanesian DNA trace that is in a lot of the Native Americans in South America. And, so there could be a possibility that you could have had in some ancient time, we're talking tens of thousands of years ago, of this possibility of this immigration coming from the Pacific. So I think it's starting to change, this whole idea of where Native Americans came from.
Yeah, and I think we need to be open to that. We need to be open to the fact that, back in prehistory, there were peoples that were much more mobile than they've been given credit for. And these patterns of migration are a whole lot more complex than the very simple, they came across the Bering Land Bridge when sea levels were lower, and they came down through the ice-free corridor, which it's plausible that people did migrate across.
Right.
But
right.
But there's a lot more to the story, I think, than that.
Well, and in all fairness, the Bering Strait hypothesis being the only the only way is also a imposed for an idea, and we're really dealing with, because there was a history of like British Israelism, and you had all these ideas that were really excessive, and the bottom line, a lot of them racist. There was such a distaste for a lot of alternative thinking for so long that now is really a time when we can get back to really talking about this stuff openly without, a lot of these old ideas of British Israelism, things like this.
Yeah, the Solutrean hypothesis as well.
Right, and the overemphasis on that, or, we're past all that now. So now we can really be honest and talk about this, but there was a distaste for a long time because of the excesses of a lot of that thinking.
Mm-hmm. Yeah, I think you're right. I think we can look at this with fresh eyes now and reevaluate our own past. And I think, that's one of Graham's messages, is that that's important to do. And, from where I'm coming from, my interest in the nonlinear, the discontinuities within the continuum of nature, which is the thing that I have focused on so much. And, of course, one of the corollaries of that is that if you accept this model that, from time to time the shit hits the fan, you then have to begin to think about how that is going to affect culture and society and human communities and so forth. And I think once you begin to look at that, you realize that there's no way that it could have had anything other than a very profound effect.
Yeah,
When once it's understood how sweeping some of these changes were, you go, okay, I'm beginning to see now why this culture disappeared as quickly as it did.
I think there's a lot to be found in the mythology of these peoples, and in particular, with the Hopis, they have a series of cataclysms. I mean, I know that's in a lot of places, but they have this series of cataclysms, and they are actually the genetic descendants of these cliff-dwelling people. So maybe, like exactly what you're talking about, there's a succession of cataclysms that has a old history that has been preserved, actually. And you can find it in mythology of different peoples around the world.
Yeah, exactly.
Sure.
Peoples around the world. I mean, this is one of the common legacy of mankind, is that there are these traditions of these great upheavals and sweeping changes and things. I mean, they're universal from all over. They involve great floods. They involve great fires. Things that could be thought of as natural disasters, but on a much greater scale than anything we've experienced, in recent history anyway. So yeah, and I think that's another big part of this shifting paradigm that we're in the middle of now, is understanding that the history of civilization is way more complex than we'd imagined and much deeper, and the history of climate and environmental change is a lot more complex. It hasn't been just everything changing on a gradual continuum of one drop of water and one grain of sand at a time, but there are literally periods, episodes where you have orders of magnitude of change compressed into a very short period of time.
Yes,
and I think that's a model we really need to begin to use to frame our understanding of the past events, including the rise and fall of civilizations.
Yeah, absolutely. I'm about 200 pages into the book, and he is with the part that I'm reading now, he's talking about South America, and he's talking about he makes this detour. Most of it's about North America, but he's talking about South America, and in particular, he's talking about the Amazon, and he talks about the conquistador Oriana, who ended up sailing clear across the Amazon into the Pacific Ocean, and seeing this amazing wealth of civilization there in the Amazon.
Yeah.
And this is built onto what also was there, the black soil, essentially, the preta, that was there, and that this was something that wasn't caused by like kind of this cause and effect trial by error, but almost it seems to him, to Graham, that this was something that was taught to these people, and the terra preta, black soil, because nothing can really grow effectively in the Amazon. It can for a time, but then the soil gets depleted. But the terra preta allows it to be mass produced, essentially, as in agriculturally. And so you've got these different geometrical shapes that are in the Amazon, these things that correspond to the Nazca lines. You have almost like this Stonehenge that's in the Amazon. And a lot of this, unfortunately, now is being discovered because of the depletion of the Amazon itself that's going on. And that so people are discovering that there was a much more advanced civilization in the Amazon than previously thought. And Graham's whole concept is that they were getting some of their technology, some of the terra preta, and some of the other things about even down to like how to make ayahuasca from some other kind of civilization. And that's utterly fascinating.
Oh, it is, yeah. The idea of a predecessor civilization that's been more or less lost to history, and that's been one of the points of contention in Graham's work since the 90s.
Yes.
You know, you get the quote-unquote skeptics, you know, who will say, well, where's the pottery? Where's the evidence? Where are the rusting, rusting bodies of the SUVs they were driving? Where is, some evidence that there was a civilization 20 or 30,000 years ago, or in the Ice Age? And the answer is, as well, you would probably expect to find some relic of some prehistoric civilization if the continuum of change went at the pace we've been seeing it for the last few centuries. But knowing, really, I mean, when you go back to 26,000 years ago, that's the onset of the last phase or late phase of, in North America, the Wisconsin Ice Age, right? So you had this, prior to that, for about 15,000 years, you had this major shrinkage of the ice caps over North America, back to just a small part of their maximum size. And then around 26,000 years ago, suddenly they reversed, and instead of shrinking completely away, they started rapidly regrowing back. And we can see this correlated in sea level rise, which is interesting because previously the assumption was that the ice sheets were more or less intact for 100,000 years or longer, which would have meant that sea levels were depressed during all of that time, 350, 400, maybe even 450 feet lower than at present. But then studies in the 70s and 80s showed that once you had radiocarbon dating online, for example, samples were taken not too far from, say, the Hudson Bay region, which would have been under 1.5 or 2 miles of ice, right, during the LGM, or late glacial maximum. So here are remains of plants and spores and pollens. So you take these, they go and they radiocarbon date these samples, and they're showing up at 30,000 to 40,000 years old. Well, obviously, okay, if you've got spruce pollen growing here at 30,000 years ago, there wasn't 1.5 miles of ice here, was there?
Sure.
So
yeah, that makes
what
sense.
this has done is confounded the whole problem of how rapidly glaciation can set in. So generally now it's, the shift occurred around 26,000 years ago, and by 18 to 20,000 years ago, we were in the late glacial maximum, and the ice sheets were at their largest extent by, 5,000 or 6,000, maybe 7,000 years later. So Then on the other end, we've got the rapid deglaciation that it still remains to be explained. But the point is that it's clearly showing that how dynamic the climate really is. And, I think that the challenge now is to try to identify the drivers of this climatic dynamism here. What is causing? Is it the sun? Is it changes in the interplanetary environment? Is it something endogenic or within the Earth itself? Is it fluctuations in carbon dioxide? But apparently not. I mean, if you're going by what the ice cores are telling us, which is the amount of carbon dioxide entrained in an air bubble, and then extrapolating from that and assuming that the amount of carbon dioxide in an air bubble is a proxy for the average global carbon dioxide atmospheric concentration, I think that's a highly questionable assumption. In other words, if you go and you extract, let's say, an ice core, and it's a half a mile down into the ice, right? And you pull that up, that ice core is maybe 5 inches in diameter, and so you've got a 5-inch footprint relative to the whole planet. You go down core, maybe 2,000, 3,000, 4,000 feet. You pull up. You're looking at an ice bubble that formed 100,000 years ago, say. You extract the bubble and you look at how much carbon dioxide is in that bubble, and then you go, okay, well, if it's 250 parts per million in this bubble, then it was 250 parts per million over the whole planet. And I think that's a highly questionable assumption. But so
right.
I digress there a moment, but then one of the issues is, well, is the carbon dioxide reservoir naturally fluctuating? If you go by the ice core results, no, it's been very stable for hundreds of thousands of years. And you regularly now hear the claim that, okay, carbon dioxide now at 410 parts per million is higher than it's been in 400,000, 500,000, 600,000 years, whatever, right? Assuming then that it never varied beyond 250 to 280 parts per million. At some point, though, it did appear to drop even below 200 parts per million, which is dangerously low because that's the point at which photosynthesis starts to shut down. And so the question, so again, there are many complex questions to try to determine what's driving these massive climate changes. It's my impression, having studied the carbon cycle, that fluctuations in the ambient carbon dioxide concentration is a result of something else, not the cause. But what they've done now for the climate change models is they've put carbon dioxide in the driver's seat and ignored other potential variables in the equation. And I don't see carbon dioxide as being the thing that's driving the climate. In fact, there's other evidence to suggest that there were enormous fluctuations of carbon dioxide, but you have to go to different proxies for that. The ice core proxies seem to show a relatively stable concentration of carbon dioxide, which would suggest then that when you go back into the Pleistocene and you look at these great oscillations of climate, what that would suggest is that, well, no, obviously carbon dioxide, if it remains stable, it's not driving these climate changes that are showing up in the oxygen isotope record of those same ice cores. So there's a lot of unresolved questions here, and it just pisses me off every time I hear some idiot say the science is settled and the debate is over, because, brother, it hadn't even started yet.
Yeah. It sounds like that, because I think I've said this before, probably once when I had you on, was that, it just seems to me like everything is in a system together. So we're in the solar system, and the sun obviously has to have some kind of effect on the climate of the Earth. I mean, that
oh, hell yeah,
should be an obvious statement. That's what's going on. I mean, I don't doubt that maybe we have contributed somewhat to it, but I think that there's a lot more.
We have.
And we've had so many climactic changes, though, at times that we didn't contribute to it. So I think it's just much more complicated than people say that it is.
See, Adam, that's precisely my perspective on it.
Yeah.
So we have the same idea on that. But, no question in my mind that the sun is the dominant factor here. And I think that there's a lot of studies. See, here it's interestingly about the time the whole global warming scenario got politicized in the early 90s. The Intergovernmental Panel on Climate Change was established, given a mandate to demonstrate the anthropogenic influence on climate change, and generally how that was interpreted as well. All we're going to do is we're going to focus on humans' role, and we're going to ignore things like the sun. Well, the thing is about that time is when we had a lot of the first solar observatory satellites going online. Actually, it started in the 50s. There was something like 2,000 instrumented spacecraft sent up over the years between, say, the late 50s and the 80s. And you had this intensive an Earth solar program with Skylab. I don't know if you remember Skylab.
I don't physically remember it, but I know what you're talking about.
Yeah. So we started making satellite-based observations of the sun, and they accelerated through the 80s and the 90s. So, like, what was it? John Eddy, who was one of the scientific godfathers, I guess, of solar physics and studies of the sun. He wrote in 1975 an article called "A New Look at Solar Terrestrial Relations," and that was post that you can see that our understanding of the sun. There was the Solar Maximum mission, or SMM, the Sol Wind expedition that created coronagraphs of the sun, and others. SOHO was another one. Anyway, so we began in the 80s, 90s, and accelerating right up through into the 21st century, collecting all of this new data on the sun. And what the new data is showing is that the sun is way, way more variable than anybody was assuming, right? Because the term that was always used before was the solar constant, right? So the idea was that solar, irradiance variability was about 0.01%, because, well, that's what we've observed in the last couple of decades, and which is true. But what we're also seeing is evidence that that is not always the case. There are times when the activity of the sun ramps up maybe an order or several orders of magnitude beyond what we have observed, say, just in the last few centuries. And that to me is really, really important stuff, but it's still being neglected in the IPCC computer models, because, again, the objective was to put carbon dioxide in the driver's seat. And so with that mandate in mind, it's written right into the charter of the organization, right? That, you're going to explore the human imprint on climate change, which is a valid and important thing to do. However, again, what I'm saying is that the science got hijacked, basically to demonstrate that humans now are the dominant cause of climate change.
Yeah, focusing too much on one aspect.
Yes, that's
right.
Exactly it.
Right.
And I think now we're seeing that, solar proton events, coronal mass ejections, the solar magnetic field is a whole lot more variable than anybody was assuming, and variability of the sun's magnetic field affects the intensity of the plasma rays striking the Earth. Then there's galactic rays that are probably emanating from the core of the galaxy, or remnants of nearby supernovas that can impinge upon the Earth, and there's this dynamic interplay between the solar wind and galactic cosmic rays and the Earth's geomagnetic field, and really just the realization that the interaction of these various processes is a lot more complex than anybody had imagined, but they can have an oversized effect on global climate. So, I'm saying, we need to look at the whole picture here, or we might get caught with our pants down thinking that if carbon dioxide is the only thing we need to worry about, we might be unprepared for some of these other variables.
Sure.
That are very real.
Well, and one of those variables would be what you talk about a lot, which is the comet impact stuff. Because the sun has a definite influence on comets.
Oh, it does. Yeah. Yep. And, the discovery of sun-grazing comets is very interesting, and shows that, that comets are playing a central role, perhaps. Let me see if I can pull up a quote here from some relatively recent work regarding the role of comets. Let's see.
Like anything, they revolve around the sun, obviously, since that's the most has the most gravitational mass in our solar system, and the whole idea of the comet tail comes from the fact that they're basically melting the closer they get to the sun. So you have that vapor, plume. Yeah.
They're also accelerating to high rates of speed.
As they're pulled in closer to the sun, right? That's how it works?
Yes, as they're drawn into the sun, the closer they get, the faster they're going to go. Let's see here. Here's Louise K. Hara. She's a solar scientist who wrote back in 2002 an article entitled "Explosive Events on the Sun." Appeared in the Philosophical Transactions of the Royal Society of London, and she's saying, this is 2002, she says, these explosive events are poorly understood and yet occur in a variety of contexts in the universe, ranging from planetary magnetospheres to active galactic nuclei. Understanding why flares and coronal mass ejections occur is a major goal across a wide range of space physics and astrophysics. Although explosive events from the sun have dramatic effects on the Earth, flares in other stars, for example, can be vastly more energetic and have an even more profound effect on their environment. And that's something else that's interesting. And, in the last decade or two, the studies of solar-type stars, there's about maybe a dozen or 20 of them that have been looked at now that have generally the mass of the sun, similar radiant outputs, the size of the sun, and so forth. And what they're showing is, in every case that we're looking at these solar-type stars, their variability is considerably more than what we've observed in our own sun in the last couple of centuries. So what is that suggesting? Is it suggesting that our sun needs to be thought of more like these highly variable solar-type stars, or our sun is unusual in being unusually stable? I don't know the answer to that question. But if the variability of some of these nearby stars that have been observed were to apply to the sun, we would be in a world of hurt here on planet Earth. So,
well, it kind of sounds like we've been in a world of hurt before.
Yeah. So here she goes on to say, we are now in the unprecedented position of having access to a number of space observatories dedicated to the sun. The Yoko spacecraft, the Solar and Heliospheric Observatory, the Transition Region and Coronal Explorer, and the Ramati High-Energy Solar Spectroscopic Imager. So these cover a wide wavelength range from white light to gamma rays with both spectroscopy and imaging, and allow huge progress to be made in understanding the processes involved in such large explosions. The high-resolution data showed dramatic and complex explosions of material on all spatial scales on the sun. They have revealed that the sun is constantly changing everywhere, something that was never imagined before. The sun appears to be a much more variable star, much more dynamic than anybody was imagining, even in the 80s and early 90s. And when the whole question of anthropogenic global warming came into the mainstream, all of this new knowledge about the sun was happening in tandem, parallel to that. But has it made its way into the national discourse about climate change?
No.
But it needs to.
Yeah, no, it hasn't.
You don't hear anybody talking about that. You don't hear, there were tornadoes. Well, it's obviously caused by climate change, or now it's the climate crisis. But yeah, and then she finally says, and she's writing in 2002, much has been learned over the past 10 years about the working of explosive events and their origin. The ultimate goal now is to understand the actual trigger of these spectacular events.
And something you pointed out before, the focus of the ancient world on stellar phenomenon, you think has to do with there being these past cataclysms.
Yeah.
And in particular, we see sun, it would seem obvious that the sun is the most prominent symbol of life-giving force, but also perhaps, there's been a focus on the sun in all these religions and mythologies because of the cataclysmic potential as well.
Well, there was always the sun god, Helios, Apollo.
Yeah, always.
All that, yeah.
Well, and then we get to this, which now this is jumping forward to 2009, in a symposium that was held called Universal Heliophysical Processes. And so this was published in the Proceedings of the International Astronomical Union. It was symposium number 257. And here's the abstract. Explosive evolution of nuclei of sun-grazing comets near the solar surface, which occurs at conditions of intense interaction between the solar atmosphere and falling high-velocity comet nuclei, as well as the relation of the phenomena of the character of solar activity, are analytically considered. It is found that due to aerodynamic fragmentation of the falling body in the solar chromosphere and transversal expansion of the fragmented mass under the action of pressure gradient on the frontal surface, goes on and on anyways, the specific energy release in the explosion region considerably exceeds the evaporation sublimation heat of the body, so that the process is accompanied by production of a high temperature plasma. The energetics of such an explosive process corresponds to that of very large solar flares for falling bodies having masses equal to the mass of the nucleus of Comet Halley. So what he's going, and then so the Solar Wind Observatory on the corona of the sun, the Solar Maximum mission, and the SOHO, which is the Solar and Heliospheric Observatory missions, they all indicate, and this is quoting right out of that same proceedings, a continuous comet flow passing close to the solar surface or colliding with the sun. Passages of comet-like bodies, extrasolar comets, and near-young stars may be responsible for observed changes in stellar spectra. So he goes on to suggest here that the passage of comets near the solar surface is accompanied by aerodynamic fragmentation of their nuclei within the solar chromosphere and transverse expansion of the fragmented mass. The sharp stopping of this high-velocity fragmented mass is accompanied by production of a high-temperature plasma near the solar photosphere and by a solar photospheric flare. So in other words, what they're witnessed, to put this all more in layman's terms, is comet nuclei plunging into the sun at these extraordinarily high rates of speed, and then you have a plasma storm forming in the chromosphere in the aftermath of these sun-grazing comets falling into the sun. And so this is very interesting. It's leading to the idea that they're, in asking what's the trigger for these, this solar activity. Then we come forward to 2015. We've got here that appeared in the Astrophysical Journal, a paper entitled Destruction and Observational Signatures of Sun-Impacting Comets. Motivated by recent data on comets in the low corona, we discuss destruction of sun-impacting comets in the dense lower atmosphere. Extending earlier work on planetary impacts to solar conditions, we evaluate the mechanisms and distribution of nucleus, mass, and energy loss. sun-impacting comets have energies comparable to magnetic flares. This is released as a localized explosive airburst within a few scale heights of the photosphere. Such airbursts drive flare-like phenomena, including prompt radiation, hot rising plumes, and photospheric ripples, the observability and diagnostic value of which we discussed. So in other words, again, in more layman terms, what's happening is you see a comet plunge into the chromosphere, and after it you see a solar storm.
So there's this almost this symbiosis or connection between comets and the sun, and the comets being pulled towards the sun, and
Yes.
the power the power of the sun increasing and pulling more comets towards it. So it's almost like this.
Yes.
It's a circle.
Yes.
Yeah.
So going on in this, he's referring back to this a researcher who back in 1981, when a lot of this data was first becoming available, this Isaac was his name, suggested that sun impactor momentum deposition could generate helioseismic waves and contaminate global helioseismic signals. This idea was discussed briefly by Gao in 1994 in the context of Jovian seismic waves induced by the Shoemaker-Levy 9 impacts. So, anyways, he goes on to say here that, helioseismic waves, sort of a more vernacular term for that they introduce is sunquakes. Sunquakes following magnetic flares. The relationship between flare and sunquake properties proved to be complex, some small flares producing very large quake signatures. The lower altitudes, smaller volumes, and faster time scales of cometary airbursts compared to flares, together with their highly directed motion, make them seem more likely to generate stronger helioseismic signatures. In other words, the comets plunging into the sun are causing sunquakes,
Okay.
which are, right, so that's what he's saying, helioseismic. We could just, instead of an earthquake, a sunquake. See, so it's inducing very, very distinct and detectable instabilities into the sun that lead to these solar storms. Now, these are small nuclei. So to me, what this raises the question is, what would be the corresponding response if you had a very large nucleus falling into the sun instead of a few miles in diameter, 50 to 100 miles in diameter?
Yeah.
What would be the solar response to that? Or what if you had a succession of impacts of comets falling into the sun during a period of concentrate, like a comet storm, which is a very feasible model that there may be times of extremely enhanced flux of comets to the inner solar system, and those that don't hit planets or ultimately disintegrate into meteor streams and finally dust, they're going to get swept up by the sun. So let's assume that we've got an epoch where for maybe a few millennium, you've got this enhanced flux of comets in the inner solar system, large comets in a lot of cases, and so you've got this regular infall of these cometary masses into the sun. And, so we have one nucleus coming in, and we see that there is a sunquake that follows, a solar storm. There may be a coronal mass ejection that follows in the wake of this impact. What if you had a series of impacts? What if you had larger impacts where the mass of the object might be 100 times or 1,000 times greater than what we've witnessed in the last 20 or 30 years? That is the kind of questions, to me, that we need to be asking. But who's asking it? Yes, there are solar scientists that are looking at this and asking that, but nobody's in mainstream media ever hears about them or their thoughts or their questions. Yet this should be part of the discussion of global change.
Time for a commercial.
If you want your HR team to hire top talent for your company, tell them about ZipRecruiter. ZipRecruiter's powerful matching technology identifies people with the right skills, education, and experience, and actively invites them to apply to your company's job posts, so you get qualified candidates fast. It's no wonder that ZipRecruiter is rated #1 by employers in the U.S. This rating comes from hiring sites on Trustpilot with over 1,000 reviews. And right now, you can try ZipRecruiter for free at ZipRecruiter.com/conspiranormal, which helps us a lot. That's ZipRecruiter.com/conspiranormal. ZipRecruiter, the smartest way to hire.
Hey, man, you'll hire.
Let me ask you this. Okay, so this brings to mind, we're talking about Graham Hancock, and I believe that he has kind of come over to the idea that you have been instrumental in espousing, and a few others as well, about this comet impact of the Younger Dryas. Now, Robert Schoch has this whole idea that it's not that, but it's some kind of solar maximum or some kind of coronal mass ejection. What you're saying here then could be that we're actually dealing with a combination of the two.
Yes.
Right.
Yes. It's not an either-or proposition. And I've heard a few things that would suggest to me that Robert might be modifying his views somewhat. But I think he's definitely onto something by invoking the idea of a highly variable sun.
Okay, so this brings me to, so we're on the subject of the comet impacts, and apparently this has been something that has been going. I mean, this is a cyclical thing, so this is something that keeps happening. And you brought up something on another podcast about the Holy Grail and the Arthurian legend that I thought was just fascinating. And tying it in with, again, the possibility of some other kind of comet impact.
Yeah. Yeah, it is. It's extraordinarily fascinating. I don't even know where to begin talking about how fascinating it is.
Yeah, well, okay, so what was extremely fascinating to me was this whole idea in the Arthurian legend. Now, whether you believe that this actually happened or not, I don't know. But in Arthurian legend, you have Mordred, the son of Arthur, by his sister, which is kind of weird. But at least that's what's in the movie Excalibur. So you have this battle, the Battle of Camlin, I guess it takes place, and there's some interesting correlations between that and some kind of really kind of extreme climate change in the 6th century AD.
Yeah. Yeah, there was. In fact, a number of paleoclimatologists using dendrochronological evidence have declared that 536 AD may have been the coldest year of the last 2,000 years. And that fits
536
right
AD?
536, yep.
Okay.
And then that was followed by a decade of extremely cold weather and the near collapse of, or I would say the interruption of the biosphere in the northern hemisphere, because tree ring studies from both Europe and North America show almost a complete cessation of forest growth for almost a decade after 536 AD. So something happened that fits, because the Battle of Camlin and the death of Arthur is usually given as about 539 to 540 AD. And then you had the Justinian plague, which swept over Europe in 542 AD, which was the consequence of the years of famine that had followed in the wake of successive agricultural collapses and people going hungry. And then, of course, when you don't get enough to eat and your immune system is compromised because of malnourishment, that's when opportunistic diseases can, jump in and wreak havoc with people, and that's what happened. You had in the wake of the global cooling of 536 AD, you had this succession of catastrophes.
Yeah, this was
agricultural collapse, famine, and then that was followed by the Justinian plague in 542.
Yeah, Justinian plague. Yeah. What's the connection there, though, to the Holy Grail, this concept? Well,
here, the idea is that, okay, the the historical context of Arthur and the quest for the Grail is placed right there in the 530s to early 540s. That's the context of those stories, is that the quest was taking place, that Arthur's Round Table, in other words, if he died at the Battle of Camelot in, say, 540 AD, then that means the events leading up to that, including the quest for the Grail, would have been right in that time frame. You see, that's the connection there. It's simply temporal, chronological. It's, in other words, you can go from the stories and you can extract these dates, 536 to 540 AD, as being the time frame in which this whole story is playing out. And then subsequent to that, you now have independent scientific evidence that, something, at least in the Northern Hemisphere, took place that was highly unusual and very extreme. And what was the point? What was the purpose of the Grail quest, if you recall? It was twofold, right? The king had gone into decline, and it depends on whose account you read, because they all vary a little bit. Wolfram von Eschenbach doesn't give the same details as Robert Deberon or Chrétien de Troyes or the anonymous author of Parlez-vous. But they all give different perspectives on it. And one of the themes that comes through regularly is the idea of the wasteland, that the kingdom, not only the king, but the kingdom itself, have fallen into decline. And what had been a fertile, fecund land went into decline. And this is when, you mentioned John Borman's movie, Excalibur.
Mm-hmm.
You recall in there he's showing, now that's primarily taken from Thomas Mallory's version of the Grail cycles.
Which is kind of a culmination of all the rest of them, essentially.
Yes.
Yeah.
Yes, that's exactly right.
The Morte de Arthur. Yeah. Yeah. That's Mallory's version. So basically, what's happening in there, if you recall, as the movie is coming to it's up to its third act, there, the kingdom has fallen in decline, and people are wandering around starving and dirty, and things look really miserable and dark, and they actually were dark. I mean, because what it's suggested now is that there may have been several agencies at work, including a couple of very large volcanic eruptions and possibly even an impact or two. There's a potential crater off the coast of Norway that's been named Grendel by its discoverers that appears to date right in there between 536 and 540 AD. Really?
So it's almost like you had this perfect storm of things that happened that caused this global downturn in climate. And in England might have been particularly hard hit. Northern Europe might have been particularly hard hit. And so what's interesting is in the Grail stories, you've got the quest for the Grail, and the Grail is the symbol of the thing that can restore not only the king, but the land as well.
The land and the king are one.
The land and the king are one, yes. Yeah. So the Grail is found, it's brought back. Arthur drinks from the Grail. Now, in some of the stories, it's on Fortas. In other stories, it's the Fisher King who is in ill health or has a wound that won't heal. Again, there are variants in the story. None of the stories are precisely the same. They're all kind of looking through their own lens at these events. But what to me is so interesting is that we now find out that precisely that period that is being represented in the Grail stories, there was actually something profound that happened. And that it really was, the land did become dark, the skies became dark, you had crop failures, and you had displaced people wandering around the countryside like zombies. And the Grail, again, the quest for the Grail, what was the Grail? The Grail was the antidote or the remedy for this malady that had engulfed the kingdom, you see. So that's the connection there. That you've got these stories of the wasteland, the encroaching wasteland, and the debilitated king, and the Grail becomes the means of restoring the health not only of the king but of the debilitated land as well.
That's fascinating. You've got all the solar symbolism in the Arthurian court ideas, and then also what's been mythologized as the end of the pagan era. So it kind of all coalesces into this possible climactic change that really just, puts a stake down in a transition between eras.
Yeah, and then in the wake of that, it was a good 300 years. The 3 centuries, so right up until the 900s, was what's typically called the Dark Ages, and it was not a very pleasant time. And there are many accounts, from monasteries and so forth, monks who were, keen observers of the weather and climate, talking about how, for weeks on end, they barely saw the sun, that there was this shroud of haze in the sky, that the summers were short and cold, lots of damp and rainfall.
And it's called the Dark Ages.
Yeah, it's called the Dark Ages, but that's not it's not just metaphorical. That's the point.
Right. I've never thought about it in that way.
Mm-hmm. Yep. So let's see here. Let me see if I can find. Okay, this is from Geoffrey Ashe, who was a Grail scholar. I think he's deceased now. In his book Mythology of the British Isles, somewhere in Arthur's Britain, there was a mysterious castle in the possession of a custodian called the Fisher King. He was partially crippled by a wound, and the land round about was a waste. No one knew where the castle was. When Percival came to it by chance and was hospitably received by its lord, he saw a procession of young people bearing strange objects. One of them was a lance with blood dripping from its point. A maiden carried a splendid vessel studded with jewels. It had a supernatural power of nourishment. The Fisher King's father, concealed from view in another room, lived on a single mass wafer, placed in it daily. Percival, though mystified, had been taught that it was discourteous to ask questions and did not inquire the meaning of what he saw. He learned too late that he should have done so. If he had, the spell would have been broken, the Fisher King's wound would have healed, and the wasteland would have become fertile again. So I think that concealed, like in so many of the myths of olden times, there is a generous dose of historical truth in there, concealed within the symbolism and the metaphors and so forth, the packaging that it's placed in. But it's just too coincidental to look at the dating of the historical Arthurian tales, the setting, and then realize that completely independent of that, paleoclimatologists have discovered evidence of a climate catastrophe, probably the most severe climate catastrophe to have engulfed the northern hemisphere in the last 2,000 years. And that for a while, Britain was literally a wasteland.
And then a few hundred years after that, they're growing wine in Britain. Then a few hundred years after that, they can't grow wine there anymore. So the climate fluctuations.
The medieval warm period came on in the 900s. One of the things that happened as a result of that is the sea ice retracted to the north, and it opened up the sea lanes that allowed navigation between Scandinavia, the British Isles, Iceland, and ultimately Greenland and North America. And, you had a Viking colony established on the west coast of Greenland during that medieval warm period, and then it was there for about 400 and some years, and then it disappeared. It went extinct, right? And the extinction of that community, of those farming communities in Greenland, coincided with the onset of the first phase of the Little Ice Age and the re-expansion of the of the northern ice flows that basically cut off Greenland from Europe. And because during the medieval warm period, you had trade going on between Greenland, Iceland, and northern Europe. And then with the onset of the Little Ice Age, the sea ice expanded and it cut off Greenland. So either they're now in a situation where they're going to either adapt or die. And presumably a lot of them died, probably starved to death. Some of them may have gone native because the native peoples were able to successfully adapt and thrive, even with in other words, when the sea ice expanded, they learned how to hunt on the ice, right? Whereas the Scandinavians were completely committed to their farming, and farming became impossible. So the Scandinavian communities in Greenland went extinct, and I think there could be sort of a microcosmic lesson there, in that you have two communities side by side, one that was highly adaptable and the other one that was rigidly entrenched into certain behavioral patterns, didn't adapt, and they went extinct. But yeah, so then you had the Little Ice Age. So you had that interim between 900 and the late 1200s where, yeah, they were growing wine grapes in England. You know, the Scandinavians are farming on the west coast of Greenland, where you can't farm now. Maybe you can, you know, if warming continues for another 20, 30 years, maybe you can.
Right.
But I suspect that may not be the case. In any case, you had major climatic changes that occurred, and it was during the medieval warm period, where growing seasons increased by weeks, if not a month or two, and you know, also the elevation at which crops could be grown increased. You know, went up elevation, up mountainsides, and so forth, and you had a whole series of very abundant crops where people had a lot to eat. So people started. What you see is, as you come into the medieval warm period, you see lifespans extending. You see infant mortality decreasing. You see the stature of people increasing quite rapidly once they have plenty of nourishment. And then, after a century and a half of this warmth, European society has created enough surplus that it's able to support, you know, these armies of craftsmen that built the great Gothic cathedrals, which couldn't have happened during the Dark Ages, because, for one thing, there was no labor pool to draw from, because population increased significantly during the medieval warm period. So it's also interesting that the rapid termination of the Gothic building enterprise coincides exactly with the onset of the first phase of the Little Ice Age in the early 1300s.
Yeah, that's where you start to get the 100 Years' War. You start to get almost kind of like this and the Black Death and all these things that happened at the same time.
Exactly. I think the Black Death was in the 1340s, and of course, once the Black Death happened, which, again, just like the Justinian plague, it came in the wake of a whole series of agricultural failures, of crops rotting in the field and people not having enough to eat. And so, you know, a generation of that, and people got weak, and their immune systems became susceptible. And then, yeah, you had the bubonic plague that came along in the 1340s. And then once that happened, boom, that was the end of it. You had no more huge labor pool to draw from, and that was the end of the Gothic building enterprise to a large extent. Not completely, but to a large extent.
Yeah, because you have this
even
12th century, 12th and 13th century, 1100s and 1200s Renaissance that is kind of like broken by the plague and by the wars and the climate change. Yeah. Well,
and then the Renaissance comes right. You know, there was a phase 1 and a phase 2 of the Little Ice Age, and there was most definitely a volcanic component to that, because we know that now that's, you know, new discoveries are showing, you know, volcanic ash and isotopic signatures showing up in ice cores that show that there was enhanced volcanism associated with the coldest periods of the Little Ice Age. And the most recent one would have been the eruption of Tambora in 1815. You know, Tambora is down there, part of that Sunda arc in Indonesia, and it erupted in 1815. And in 1816, you've probably heard of this, it's called the Year Without a Summer.
Yeah.
And scholars who have looked at that call it the last great subsistence crisis in Western civilization, because you had mass starvation. Because again, in New England in July 4th, they were having a July 4th celebration in a snowstorm, basically. So, yeah, the 1816 Year Without a Summer, and it took 3-4 years before the skies cleared from that eruption, and we're learning that those big volcanic eruptions are having an enormous effect. The sulfate aerosols that they eject into the atmosphere can block the sun. So it's not only just a matter of the ash and the dust that darkens the skies, it's also the sulfate aerosols that are absorbing the solar radiation up in the stratosphere and preventing it from reaching the surface of the Earth. So you have these global cooling events. And, here's the thing. We built a civilization that's quite vulnerable, really, to the kinds of natural climatic and environmental changes that have now been overwhelmingly documented. And I just don't think we're paying enough attention to that. You see, we're so busy beating up ourselves that we're in the driver's seat now that I think maybe we're not. And we need to seriously consider that there are other factors and learn from these examples in history and prehistory that are, both are replete with these examples of civilizations that were highly stressed, if not exterminated altogether, by natural variability.
Yeah, and it seems it's an ongoing process, and it's an ongoing story. Because when I think I've told you this before, when I look at this concept that we call Atlantis, it's almost to me that we're talking about many civilizations that have been destroyed by these natural processes. Like in my opinion, when I look at what Atlantis that Plato was writing about, I think could have been Crete and Santorini, and we know that primarily was due to the volcano eruption. You have whatever happened in the Black Sea area, where this natural dam gave way and just flooded this entire area, and you have the Bronze Age collapse, which you have things that are lost from it, and then you have whatever happened in the Younger Dryas, which the possibility that there was, so it seems that there was a catastrophe that ended some kind of maybe more advanced civilization. Then, this seems to be an ongoing process, and it seems to go in cycles.
It seems to go in cycles. Yeah, there's evidence that there's a cyclical nature to some of these things. And my reading of Atlantis, which is primarily based upon Plato's dialogues, there's not a lot other than those. I mean, a few comments by Proclus based upon the writings of Crantor, but again, we don't have the original writings of Crantor. I wish somebody would find those someday and discover that, here's a whole other account of Atlantis. But most of what we have on Atlantis comes from Timaeus and Critias. But what he's describing really is more like a more elaborate Minoan or Phoenician civilization. He's describing a maritime culture. He's not describing crystal technologies or flying ships or aliens or anything like that.
People riding dinosaurs.
No, I don't recall him talking about riding dinosaurs. I think that came along later, right, with Fred Flintstone?
Yeah, something like that.
Yeah, I think that was a later concept. So what he's describing really sounds like maybe a scaled-up version of the Minoan culture. They're carrying on navigation and trade. They have colonies. There's nothing so extraordinary about that. Yet, interestingly, still, although not as much as 3, 4, 5 years ago when I first started presenting some of this information on a larger scale, like on Joe Rogan and stuff, people would say, "Oh, well, I was listening to his stuff, and then I heard him say Atlantis, so I knew this is a bunch of bullshit, so I turned it off." Oh, okay. Yeah, I mean, there was a lot of that, you know, like you can't even mention the word Atlantis, and all the idiots that, you know, I mean, you probably have heard of the Dunning-Kruger effect. You familiar with that?
I'm not familiar with it, but is it maybe just like people go to a preconceived notion? Is that the concept?
Well, it's basically people who are too stupid to know they're stupid.
Okay,
basically.
well, yeah, there's plenty of those.
And there's a lot of those.
Yeah,
there are a lot of those.
I was giving them too much credit, Randall.
Yeah, you are. Yeah. People who are too stupid to know how stupid they really are.
Yeah.
And, you know, I see their remarks all the time, you know, to which I would say, okay, so you've read Timaeus and Critias, you've read Plato's dialogues, and you know what he's talking about there, but of course, no, they wouldn't even be able to tell you the name of a Platonic dialogue. In fact, the same thing, but I heard him talking about the Holy Grail, so I knew he was full of crap, you know. So, you know, it's like, okay, well, never mind. I'm not really too interested in trying to educate you anyway, so you can go back to whatever rock you crawled out from and just stay there and quit bothering the rest of us. But yeah, so there's a lot of misconception about some of these things out there, and certainly the Grail is an example of that, and Atlantis is an example of that, where people think that, you know, somebody, well, I'm a rational person, so I don't believe in Atlantis. Anybody knows that that's fiction, but just like with all myths, what you have to do is you have to look and realize there's a core of truth to these things. Now, what form that takes, it takes study and scholarship to extract that information. But the Atlantis story, and you know, Plato repeatedly confirms the veracity of the account. A lot of the commentators later said, well, he just meant it as a metaphor for his idealized version of the political state, right? And he didn't mean any of it literally. Yet, if you read the dialogues, he says over and over again, "Yeah, this is. I do mean this literally. I'm not making this up. I heard this, and I'm telling you it exactly how I heard it." So, I mean, his own words states the veracity of the accounts. So, you know, did he make it up? Maybe, but maybe not. So we have to look, and then when you follow his clues, what you discover is that his geography and his geology and his astronomy are right on. I mean, you know, when you start looking at the specifics, as I've done, taking it detail by detail by detail, you discover that, see, and my problem with the Santorini thing is you have to alter his account by an order of magnitude, because the eruption of Santorini was around 900 BC, roughly, I think, right in there. And, of course, he is placing the final destruction of Atlantis at 9,000 BC. You see, actually 9,000 years before Solon's exile in Egypt, which apparently was between 500 and 600 BC.
I almost think that I would... I almost think that I would explain some of that as just this kind of confusion of everything was being lumped together. All these different civilizations may have been being lumped together into one thing.
Mm-hmm. And the Minoan civilization on Crete, I mean, it suffered a catastrophic collapse. It may have not been in one fell swoop. It may have been like it got walloped a couple of times, and then it struggled to recover, and then it got walloped again and couldn't recover. But yeah, there are many instances of, like you just said, the Bronze Age collapse, which occurred all around the shores of the Mediterranean. You had, you know, clearly natural disasters, I think, that precipitated this cultural response. And in some cases, it may have ultimately had an extraterrestrial cause to it. If not, you know, endogenic means within the Earth in this context, exogenic from outside. So I think it's a combination of both. I think we have episodes of extreme volcanism, which can play havoc with the climate, and then we have many more extraterrestrial or cosmic factors to consider. We've been talking about the sun. We've been talking about impacts. Hey, if nothing else, there's the possibility of the accretion of cosmic dust, which could increase the opacity of the atmosphere, reducing solar radiation and bringing about a general darkening and cooling of the climate. So, I mean, there are many factors we need to be looking at here. Also, fluctuations in the Earth's geomagnetic field, which is another factor that needs to be looked at. The solar magnetic field, the galactic cosmic rays, as we were talking about. All of these things are now factors, and this is why I've been saying for years now we really need to start thinking in cosmic terms. And if we really want to understand terrestrial ecology, we have to think in terms of a cosmic ecology, because many of these factors, including likely the introduction of organic molecules and things into the biosphere, might ultimately be cosmic. So we need to be looking at a larger framework. In order to understand global change, we have to look at it in the context of the larger cosmic framework.
Yeah,
and
I agree.
Endogenic, volcanic could, in some cases, be a response to changes in the cosmic environment. Right now, I'm immersed in the study. I've kind of come full cycle around, and I'm looking back at the Cretaceous Tertiary extinction of 66 million years ago, when the dinosaurs and the ammonites and various other, the graptolites and the polysopods, I can't hardly say that word, disappeared. And it appears that it was a combination of cosmic and volcanic, because that was when you had the outpouring of the Deccan traps in India, that is now, with new dating, shows that it's, and this is kind of why I've kind of gotten back into it, a lot of the new dating shows that the extrusion of the Deccan traps was much shorter than previously estimated, and that it was exactly straddled the KT boundary. So it's like you had this major volcanic activity going on that would have been pumping billions of tons of sulfate aerosols into the atmosphere, possibly huge amounts of carbon dioxide and other volatiles. And then at the same time, you've got at least one great impact, and the impact geology is suggesting that there was actually a prolonged period of clustered bombardment straddling the KT boundary. So the KT boundary is a good example, I think, of where you have this sort of perfect storm of things going on. Now, there's evidence from Indian geologists that there may have been a major impact into the Indian Ocean. They're calling this the crater, the purported crater Shiva, and this is the name they've given to the impact. If there was a large impact into the Indian Ocean, contiguous with the Deccan traps outpouring, that may have been the trigger for it. And that's another thing that I think that we're learning, is the possibility that a lot of the great volcanic events may be impact related. There's concern now over Yellowstone and the volatility of Yellowstone. But what you have there is a mantle plume, a deep mantle plume that goes back 16 or 17 million years, and the Columbia Basalt Plateau, which now covers a large portion of eastern Washington, was the basaltic extrusion from that particular mantle plume that is now under Yellowstone. Well, David Alt, a geologist from that region, proposed in a book, about 20 years ago, that you may have had a major impact that due to the density of the object, its velocity, and its angle of approach, was able to punch largely through the crust, and through pressure relief melting, allowed this upwelling of magma and literally created the magma plume that is under Yellowstone. And I think that's a very interesting idea, that right now the dominant ideas about mantle plumes is that they're totally endogenic. They're completely subject to internal terrestrial processes. But I think we're seeing more consideration of the idea that at least in some cases they may be externally triggered. And if that's the case, then we're having to look now at, reconsider things like geomagnetic field reversals, which may be related to impacts, large episodes of volcanism, which may be related to, again, changes in the cosmic environment. We need to be looking at a much more variable sun than anybody was thinking about 20 or 30 years ago. And, yeah, we're at a whole new stage, a whole new threshold of understanding how our world works. And this is why I get frustrated, because it seems as if there's an attempt to constrict the discussion and the dialogue to pre-approved ideas. And some of these other ideas, which I think are as important, if not more important, are getting marginalized. Because, how often do you pick up the paper and read about the climate crisis that we're in the midst of compared to new research on the dynamic variability of the sun? I don't even see a comparison, because every day I go online or I pick up the paper, I turn on the television, and there's something about the ongoing climate crisis. The spate of tornadoes we had last week, clearly climate crisis, right? Every weather event now is part of the climate crisis. And the climate crisis is, again, presumably all brought on by 100 parts per million increase in carbon dioxide concentrations in the atmosphere. And I think it's fair to question that.
I think it is too. And I think that's a good place to close it up. We covered a lot of ground. Randall, what we're going to actually do with you, we're going to do something we don't normally do. We're going to close the show with you on air, if you don't mind.
No, I don't mind.
Okay. Well, first of all, tell people where they can find you and see all the great work that you're doing. And if anybody doesn't know Randall Carlson by now, you've been living under a rock, so I don't know.
Geocosmic Rex, Brad Young's put up a website. He's been my traveling buddy for a quarter century now, and he's documented extensive documentation of a lot of the stuff we've been doing, and he's been filming lectures and seminars and field trips. So you got a whole bunch of stuff on Geocosmic Rex that people can find. And Sacred Geometry International, which is Cameron Wiltshire put that website together, and it also has a lot of great information on it, things that people can download, articles and essays that I've written, and so on. I think you're going to, and there's going to be more. I'm writing regularly now, and one of my goals before the year is out is to have my first book finished. I've got about 90,000 words written so far. Need to write about another. I'm going for about 120,000 words, and then that needs to be cleaned up and edited and so on. And I don't know how long that's going to take. Hopefully, not too long. But yeah, I'll be covering a lot of this stuff. It's going to kind of be a smorgasbord, introducing people to some of these ideas, and then I've got a couple of follow-up books. I definitely want to do a book on the Grail, and where we really get into a deep analysis of the symbolism and the correlations, some of the stuff that we were talking about this evening on in the interview, and some of the science that supports this fundamental idea, which is one of the ideas I'm proposing to be tested hypothetically, which is that the Grail is a symbol for a technology whose purpose is restoration of the wasteland. In other words, it's a technology that's designed, whose purpose is to restore fertility and stability to the land, the planet, whatever scale you want to look at, in the wake of a natural catastrophe. And that's essentially the premise that I'm working from in the material that I'm writing on the Grail. So I've got several things in the pipeline that hopefully will be out there by the end of the year. We're also possibly looking at some more field trips. I would like to I've got several really awesome field trips in mind, similar to what we just did these past couple of weeks in Colorado. So, there will be, so people go to your website, go to Grimerica also.
Yes.
There will be announcements on that. The Brothers of the Serpent, who were participants in the adventures out in Colorado, are posting information on their on their podcast site, and I'm probably going to do another podcast with them in the near future. So there's a bunch of sources out there that people can access. Geocosmic Rex, you'll have over 100 video clips you can watch.
Cool.
Yeah, man.
Very cool. Very cool. I'm looking up the Brothers of the Serpent right now. Thank you so much, Randall. Stay on the line for us. We're going to close out the show real quick. Seraphiel, tell everybody where they can find us on Patreon. Where they can
go
sign up to support us.
To patreon.com/conspiranormal. Make a one-time donation at conspiranormal.com.
Absolutely. Send us some money. All right. Well, that's it, guys. We're just gonna end the interview. We'll find a place to put the advertisements, I guess. So, guys, join us next week. We'll be back. We're gonna talk about some reincarnation and some near-death experiences. Looking forward to it on Conspiranormal.
If you would like to help the show, please consider becoming a Patreon at www.patreon.com/conspiranormal or leave a one-time donation at conspiranormal.com.